Welcome sa akong pinakaunang topic for my general chemistry series. And this lesson or topic will be talking about subatomic particles and chemical elements. Okay. So, ang pinaka sinugdanan gid sa tanan-tanan nga naa diri sa existence nato is the Big Bang. Though this has not been proven yet, but it's still a theory. But mo na siya ang pinaka-plausible theory, scientific theory behind the beginning of everything, like the history sa universe. So, sa Big Bang theory, it was theorized nga isa ka very immense explosion. Uh, it's like a big bang. And after that explosion, nag-cool down ang tanan entities, matter, and everything sa universe. And then, all of a sudden, via slow processes, form ng mga elementary particles, which later on form the atoms, and then compounds, then molecules, and then eventually, kung unsa ang naa sa present day, like humans and planets, their constellations, etc. etc. So, ang after sa Big Bang Theory, naay upat ka fundamental forces nga na-form, and these are electromagnetic forces, weak and strong forces, and the gravitational force. Kaning upat ka forces mo ni sila ang fundamental forces in nature. Sila ang make up about everything when it comes to matter and energy. So kaning upat ka forces ang present, no, sa atong kalibutan and everywhere in the universe. So, yes. And sa particle physics, naay ginatawag nga standard model of elementary particles wherein diri gina-describe ang tanan elementary particles of all the fundamental forces in the universe except gravity. Okay. Ang gina-describe lang aning mga elementary particles are electromagnetic force, the weak and strong nuclear force. Okay? So kaning elementary particles, they are categorized into one category or one set of elementary particles are called fermions and the other ones are bosons. Ang kaning fermions, mo ni sila ang mga elementary particles na responsible for comprising matter. Okay? And whereas kaning mga boson particles, they are interaction particles. Sila ang elementary particles responsible for like intermolecular forces and any interaction, from one object to another object. So these are composed interactions like this um, is comprised of like this boson particles. Now, ang kaning standard model, nalagi ni siya limit kay ang iyang gina-describe ra ani as what I've said is only the three forces, electromagnetic, weak, and strong. And gravity is out of the picture. Now, ang scientists karon, like particularly the physicists, they are trying to identify the elementary particle responsible for the gravitational force. And that is mo na siya ang isa sa mga challenge karon sa ginatawag nato nga string theory, which is mo na siyang ginastudihan for so many years sa mga theoretical physicists na gusto nila ma-prove ang existence sa elementary particle responsible for gravitational force or the gravity. Once ma-complete na ning once ma-identify or ma-determine nila ning elementary particle for gravity, then the string theory could be a universal theory that will describe all these uh, four fundamental forces in just one equation. Okay? But as of now, wala pa ni na-prove ning string theory. So in chemistry, which is a different kind of field of physics, we are only bound sa tulo ka subatomic particles, namely electron, proton, and neutron. Now, in the standard model, ang subatomic particles sa chemistry nga nabilong lang sa standard model is only the electron. okay, here, and an electron is a fermion, which is a particle responsible for the occurrence or existence of matter. Ang proton and neutron, dili sila appear sa standard model because they are bigger particles and they are composed of quarks. Here, these 6 elementary particles are uh, the different kinds of quarks. And in particular, ang protons comprised siya of 2 ka-up quarks and 1 ka-down quark. Okay? Whereas ang neutrons is only isa ka-up and duha ka-down quarks. So that is how protons and neutrons um, uh, gina-compose in terms of quarks. Okay? So in terms of like kung i-compare nato aning tulo ka subatomic particles, so ang sa chemistry language, ang ilang symbolism is different and it depends on their atomic charge. Like for example, electron is some textbooks use just the small e or e negative, and proton is just p or p plus, and neutron is n or n zero here. So the reason for this, and this symbolism is that ang atomic charge manggod sa electron is -1 and proton is +1 and the neutron has 0 net charge. So mo na siya nga N0, P plus, and E minus ang iyahang symbol. When it comes to electric charge, electrons and protons pareho silang magnitude but different lang ang signs. Okay? Negative charge ang electron and positively charged ang proton. Okay? And they interact kaning electron and proton because they have opposing charges. Okay? Whereas a neutron naman wala siya charge. And when it comes to atomic mass, mo ni ang lahang respective masses, atomic masses at the quantum scale. Grabe kagamay kayo nga number. Okay? They're very, very small. Like this, particularly this electron is like almost nothing. It's like almost, it doesn't like exist in nature tungod sa iyang kagamay and kagaan. Okay. And particularly kaning protons and neutrons, ang totality aning duha, like the total number of protons and neutrons in a given atom is called nucleon or nucleons. Okay. So ang chemical elements, they are of course very familiar ta ni nila, and they are symbolized according to their to some based on some letters in their names. Like for example, carbon and oxygen. So isa lang siya ka letter. Okay? And they must be capitalized. But if element has 2-letter symbol like neon here, only the first letter should be capitalized and the second one must be in lowercase. Okay? So very, ano na siya, very basic. And also, kanina mga elements dito sa left, ang symbols nila is derived sa ilang name mismo. But there are also elements nga ang ilang symbol is quite different sa ilang name. That's because they are derived from Latin names. And there are 8 of them, like sodium here is derived from natrium, which is a Latin word, and potassium, kalium, then ferrum for iron, manang Fe siya, then argentum for silver, that's why Ag, and then stannum for tin, that's why Sn ang symbol, and then stibium for antimony, that is why Sb, or rather Sn, then Sb, and then aurum for gold, and then plumbum for lead. Okay. And apart from that, napoy isa ka element nga derived sa German name, which is tungsten. Iyang symbol is W, which is wolfram. Okay. And ang chemical elements, there is one general like symbol for describing chemical elements, and it's actually this one. Like there's a big E here, it's a symbol for the chemical element, and then there's superscript A, which describes the mass number or nucleon number, ang mass of nucleon number, they are the same. Okay? And for this lecture, I will use the term nucleon number. Ang nucleon number, this is a number, this is just the sum of the total number of protons and neutrons in a given atom. Okay, mao na siyang nucleon number. And ang Z here is the atomic number. And take note that the atomic number is described by how many protons are in the atom, in the nucleus in the atom of the atom. Okay, so it's not the electrons that describe the atomic number, but the protons. But for a given neutral element, ang number of protons should be equal to the number of the number of electrons should be equal to the number of protons. And this is the picture of the structure of an atom. So ang proton and a neutron is not as a nucleus. In other words, in the nucleus, nucleons can be found here in the nucleus. So protons and neutrons are nucleons. Okay, and ang electrons are just just outside the nucleus, surrounding the nucleons. Okay, these are electrons here. So just to show a picture of how a structure of an atom looks like. And there is also a species called isotope. And kaning mga isotope, mo na siya ang mga chemical species na para sila nga element but different sila in terms of the number of neutrons. Okay? So, pwede po natin siya maingon nga same sila of atomic number or number of protons but different nucleon number here. Just like these three isotopes of hydrogen, which is protium, deuterium, and tritium. Kani sa deuterium, this is quite heavier than the normal hydrogen, which is protium. And ginagamit na siya for NMR spectroscopy, and mostly sa NMR spectroscopy, ang imong sample ginadissolve nimo sa ginatawag nga deuterated solvent, meaning kato siya nga solvent, like for example methanol, ang iyang mga hydrogens or protiums niya kay replaced with deuterium isotope. Okay, and kani sa tritium naman ginagamit siya for radioisotope labeling, especially for analysis of marine biotoxins. Very ni siya, in demand ning tritium. Okay, this is radioactive kaning tritium. And when we identify or determine the number of protons of these three isotopes, remember that they are of the same element, so meaning they should have the same number of protons and atomic number. So all of these three should have only one proton here. And the proton here is symbolized as a red circle. So here, one circle, red circle in the nucleus, and also here and here as well. And the number of electrons, remember that in a given neutral species, ang numbers of protons should be the same with the number of electrons should be the same with the number of protons. That is why kung unsang number of protons here, mo po the number of electrons. 1, 1, 1. And as you can see in the electron cloud, this green circle, all of these isotopes all have one electron that will compensate for the proton at the nucleus of each of these isotopes here. 1-to-1 ratio of the electron and proton here. But the number of neutrons actually do not interact with the electron, but only it only interacts with the proton in the nucleus, and the forces responsible for it is the strong nuclear force. Okay, and a neutron's proton is 0 because the nuclear number, if you deduct the number of protons with it, which is 1 minus 1, it becomes 0. So that's the number of neutrons. Walay neutrons ang proton here. So why wala kay yellow circle. But when in deuterium there is 1 neutron, 1 yellow circle here, and 2 minus 1 is 1, so there is 1 neutron. And for the tritium there are 2 neutrons here, because 3 minus 1, That's the number of neutrons. Ang pagkuha sa number of neutrons is just the subtraction. I-subtract lang nimo ang nucleon number sa sa number of protons or sa iyahang atomic number. Okay. Of course, atomic number, they are the same element, so they have the same atomic number because, as we all know, atomic number is described by the number of protons here. And a nucleon number is just the superscripts here, 1, 2, and 3. Nucleon number is the same as the mass number. And another example is neon, carbon, and 1 iodine here. Neon 22 and carbon 14, and carbon 14 is used for carbon dating. When we say carbon dating, it's a method for identifying the age of a certain object or artifact. Bisag unsa pa na siya kadugayon, no? Bisag ancient times pa kay na siya ma-determine ang iyahang age via carbon dating using this isotope. And kanipod si iodine 131, ginagamit niya siya for nuclear medicine, especially for the treatment of thyroid cancers and stuff like that. Okay. And number of protons of the neon is 10 here, and the carbon is 6, iodine is 53 because this is the atomic number of neon, carbon, and iodine. Ang number of electrons, since these are all neutral, same for just the number of protons. Ang number of neutrons will be different. You just have to subtract, to get the difference of this and this. So 22 minus 10 is 12, 14 minus 6 is 8, then 131 minus 53 it's 78. So that's the number of neutrons. And for atomic number, it should be the same with the number of protons here. And the nucleon number is just the superscripts here, carbon 14, 131. Okay, another example, for an appropriate symbol indicate the number of protons, neutrons, and electrons in an atom of barium 135. So we are given barium 135. So any number after this word, like any word of a chemical element, that's the nucleon number. Like iodine 131, carbon 14, neon 20, or 21, or 22. So first button is check the periodic table and find the atomic number of barium, and it's 56. So the protons of barium is 56. Since barium is neutral, ang iyang electrons is also 56. But ang iyang nucleon number, ang iyang neutron is different. As I've said earlier, the nucleon number is the sum of the protons and neutrons. So just substitute the values in here for the nucleon number and protons. So 155, oh sorry, this should be 135, not 156, sorry. 135, then 56, then solve for neutron here. I-transpose nimo ning 56 to the left, just a simple algebraic manipulation, then you'll get 79 as the number of neutrons. Sorry, this is 135, not 156. And for the ions, in ions, anong na may ions like when a certain chemical species undergoes a reaction or lose or gain of electrons, that certain species mahimo siyang ionic. Okay, and there are two sets of ions: cation, which is positively charged ions, and anions, which are negatively charged ions. Okay, ang pagkuha sa proton o neutron for an ion here, regardless kung cation siya or anion, the same ra sa katong previous examples, but ang pagkuha sa electrons, number of electrons, would be different. Ang formula is for a cation, imo rang i-minus ning kaning atomic number or the number of protons with a given number x. So kaning x dire, this kuan ni siya kanang number ni siya nga nagdetermine sa charge sa ion. Like for example, 1 plus, 2 plus, 3 plus. Okay? Because ions have charges. Okay? Ang pagkuha sa number of electrons, kuha na nimong difference aning z and x. Ignore the charge. Okay? But when we speak of anions, the operation would be different, opposite. Kuhaon mo ang sum sa z and x, which is a certain number of the charge. Okay? Disregard the charge, the symbol, um, disregard the charge here kung negative ba siya or plus. Basta an ion gani, which is negatively charged, sum ang operation. I-add ni mo ning duha. Okay. For example, oxygen, it's a molecule. Okay, it's not an ion. So since it's neutral oxygen, molecular oxygen, same ra yang protons. Here, ang iyahang neutron is 8 because 16 minus 8 is 8. Ang iyang nucleon number is 16. And ang iyang electron is 8 since neutral man siya. So electrons should be equal to the number of protons. But if becomes an ionic, like this oxide ion here, which is a 2 minus negative 2 charge, same gyapon ng proton and neutron but different ng operation for the electron. Since this is an N ion, i-add ni mo ning duha, 8 plus 2, and that would become 10 based on this formula, Z plus X. Okay? This is Z, this is X. I-add ni mo ang Z ug X and substitute the values, 8 plus 2, that's 10. So if we describe it in a like atomic structure, si molecular oxygen nalan siya 8 ka protons, which is described by, for example, yellow spheres. 8 ni siya kabuok and 8 po ang neutron and 8 po ang electron. 1, 2, 3, 4, 5, 6, 7, 8. But when it becomes an oxide ion, na-gain siya duha ka electron here. So in order for it to have a total of 10 electrons, so same gyapon ang number of protons and neutrons in the nucleus, but the electrons now became 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here there are 10 electrons. Okay, so another example, by the way, this is an incorrect, it's a typo here, just ignore this. The neutral neon should have the same number of protons, neutrons, and electrons. Okay, but when it becomes ionized, like neon 1 plus here, basta gali 1 ang magnitude or ang number, dili na siya gina-write or ginabutang. Automatic ang charge ra, positive or negative. So same gyapon na yung proton and neutron as is, but since this is a cation, you just have to subtract. You just have to get the difference between 10 and 1, or x here. X is 1. Okay, so 10 minus 1 here, that becomes 9. So 1 na yung number of electrons. Like in the neutral neon, there are 10 electrons, right? 2, 4, 6, 8, 10, 9, 10. Whereas in the ionic form, nakuhaan og isang electron. 2, 4, 6, 2, 4, 6, 7, 8, 9. So this corresponds to the 9 electrons na gikuha nato based on this formula or equation.